Hey guys, welcome back to the channel. Today we are diving into one of the most iconic datasets in data science, which is the Titanic Survival dataset. So we will predict whether a passenger survived or not using logistic regression, and we will evaluate our model using the right metrics for classifications. No GPUs, no heavy compute, just Python, Pandas and Scikit-learn. So let's get started. So the Titanic dataset is a classic in the data science world. It contains information about passengers like their age, gender, ticket class and whether they survived. Our goal is to predict survival using logistic regression and evaluate the model using metrics like accuracy, precision, recall and AUC-ROC. So first, let's load the dataset and take a quick look at it. So we will use pandas for this. So import pandas as PD, import pandas as PD. Now URL equal to. So this is the URL. I will mention this URL in the description. So after this data equal to pd dot read csv, which is URL. Now display the first 5 rows. So for this we use data dot head. Now run. So passenger ID survived, passenger class. Here we can see column like passenger ID survived, P class, name, sex, age and more. So our target variable is survived, where 1 means the passenger survived and 0 means they didn't. So now let's move to the data processing step. So before we build our model, we need to clean and pre-process the data. So let's handle missing values and convert categorical variable into numerical ones. So first handle the missing values. So for this we use column age equal to data age dot fill na. So data age dot median. So it will fill the missing age with the median. Okay, now after this data embarked equal to data, so dot fill na. Now after this dot mode, so it will fill missing embarked with mode. Okay, now after this convert the categorical variables. So here we use the data equal to this, the column is sex equal to data, so sex dot map using the parenthesis. So here we use male 0 and for female is 1. Okay, so now embarked, change this one as well. So S equal to 0, C equal to 1 and Q equal to 2. Now after this create a family size feature. So family size equal to data. So it's a sum of sibling sp plus data, so plus 1. Now after this drop unnecessary columns. So data equal to data dot drop. So passenger id, after this name, so ticket, cabin, mm, sib sp, and the last one is now axis equal to 1. Now display the first few rows. So for this we use data dot head. So we filled missing age values with the median age and encoded sex and embarked as numerical values. So we also created a family size feature and dropped columns like name and cabin that won't help our model. Now let's split the data into training and testing sets. So for this from Scikit-learn dot model underscore selection, so import train test split. Now define feature x and target y. So x equal to data dot copy. So survived x is equal to 1 and y equal to data survived. Now after this split the data. So for this x underscore train comma x underscore test y underscore train y underscore test, so equal to train underscore test split. So it will get the parameter. The first one is feature, the next one is target variable, which is y. Now test size is 20% and random state equal to 42. So run this. Okay, we got an error. Okay, so it's a data dot drop, not a copy. Run. Okay, so now after this time to build our model, we will use logistic regression and evaluate it using metrics like accuracy, precision, recall, and AUC-ROC. So for this, import some libraries sklearn dot linear underscore model. So import logistic regression. Now after this from sklearn dot matrix import accuracy score, precision score, recall score, f1 underscore score, and after this ROC AUC score. Okay, now initialize and train the model. So here we use the model equal to logistic regression. So max tire, which is 1000. So increased max tire for convergence. For convergence. Okay, now after this model dot fit. So here we use the X train and Y underscore train. Okay, now after this make a prediction. So Y underscore predict equal to model dot predict, so X underscore test. Now after this Y underscore predict underscore probability. So model dot predict probability X underscore test, and here we use 1. Okay, now after this evaluate the model. So print model performance, print formatted string, accuracy, so accuracy score. So here we use the variable y underscore test, y underscore predict 2f. Okay, now after this copy this one, paste, and here we use the PRECI precision, and precision under score. Okay, now after this again here we use the recall, so recall underscore score. So here we use the y test and y predict. Now after this print f1 score, f1 underscore score, and after this the last one is AUC-ROC. So ROC underscore AUC score. Now change the last variable y underscore predict underscore probability. Now run the code. Okay, we got an error. Could not convert string to float s. Value error. Okay, so the error is here. It's a spelling mistake. Now again run. Start from the beginning. Run this one as well. Now after this, and run this. Our model achieve an accuracy of 81%, precision 79, recall of 73%, and uh, AUC-ROC of 88%. So these metrics tell us the model is decent but has room for improvement. So especially in capturing true survivors. So let's make a look at which features were most important for the model's prediction. So here first inspect feature importance. So importance equal to pd dot data frame. After this column name is feature x underscore x dot columns, comma, after this CIENT, so model dot COEF underscore 0, so dot sort underscore values coefficient ascending equal to false. Now after this print slash n feature importance. Now after this print importance and run. So higher fair and large family size were associated with higher survival chances, while lower age and higher P class, P class means lower ticket class, were associated with lower survival chances. And there you have it. We predicted Titanic survival with 81% accuracy using logistic regression. We also learned why metrics like precision recall and AUC-ROC are crucial for evaluating classification models. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more data science tutorials. See you in the next video.